So the next topic would be phase diagrams. So what is meant by phase diagram? It is a graphical representation of what phases are present in material system, various temperatures and pressures and composition. That means the temperature and pressure, which are all the most important parameter in phase change process. Because phase change is nothing but from one state to another state, the material can be transformed is called phase change process. If we consider an example, then we can come back to this diagram. Okay, that means if you are considering a ice cube, so if this ice cube, if you are increasing the temperature, okay, first of all, just go with this diagram. If we place the ice cube here, ice cube is at 0 degree centigrade. So if it is 0 degree centigrade, then it can be framed in the ice cube structure in solid state. So ice cube, we all know about that. Ice cube will be in the solid state at 0 degree temperature. Slightly we are increasing the temperature. Okay, what happens? So the ice cube will become melting into water. So if you are increasing the temperature around 30 to 40 degree, that means it's under the room conditions or atmospheric temperature. So you all know about that, the atmospheric temperature around 30 to 40 degree. So if you are increasing the temperature up to 40 degree, then what happens in the ice cube? Then ice cube is getting melted and it can become as a liquid state. That means if you are increasing the temperature from 0 degree to 40 degree, then it is under the state of liquid. And also we are increasing the pressure up to atmospheric pressure. That means we all know about that, the atmospheric pressure. So up to the atmospheric pressure and atmospheric temperature around 40 degree, then this ice cube is melting it into the water. That means a liquid state. The phase change, that means from solid phase to liquid phase. So this can be transferred while increasing the temperature. Then I'm expanding the temperature again. Now you see I'm melting up to 40 degree, then I can get the liquid. If I am increasing the temperature again, furtherly I am increasing the temperature up to 50 degree, 60 degree, 70 degree, 80 degree. So what happens? So up to 100 degree centigrade, this water become boils. This water become boils. Then the bubbles will come after the 100 degree. After the 100 degree centigrade, what happens? The steam can be processed. That means it can be the liquid state is transferred into the gaseous state. That means that liquid state is transferred into the gaseous state of 100 degree temperature at atmospheric pressure. 100 degree temperature at atmospheric pressure, we can have a liquid into a gaseous state. So this is nothing but the phase change process. That means a solid state of ice cube is melted into the liquid state. That means solid state is converted into the liquid state of increasing the temperature from 0 degree to 40 degree. Then continuously we are increasing the temperature of 40 to 100 degree. Then the liquid state is going to gaseous state. That means if you are increasing the temperature above 100 degree, then the steam can be formed. Okay. Simply you are saying that we are reversing this process. Okay. We can take the steam. Okay. We are cooling down the process. That means condensate the process. If you are cooling down from 100 degree to 40 degree, then what happens? If you are cooling the steam to 40 degree, up to 40 degree centigrade, then this gaseous state will become as a liquid state. That means around 40 degree temperature, we are getting liquid state, completely pure liquid. If we are again condensating, that means freezing, again condensating the process, again cooling down the process. If you are cooling this liquid up to 0 degree centigrade, then what happens? This liquid will become as a solid material. So this can be done in reversible manner also. So this ice can be converted into liquid and this liquid is converted into gaseous state of vapor, water vapor. So this is nothing but a phase change process. So this phase change process, we have having most important parameters are pressure and temperature. So these are all the two important parameters we are having. So let me take it out an example of this ice cube around, what is the temperature? Around 0 degree temperature. Okay, 0 degree temperature, we are taking the ice cube. Okay, uh, we need 40 degree temperature to comes back to the liquid state when it is in atmospheric pressure condition. That means atmospheric pressure condition, the liquid when it will become as a complete pure liquid around 40 degree temperature, that means room temperature. Okay, it takes up to room temperature to completely make it into the pure liquid. But if you are increasing the pressure into a pressure up to 10 bar, okay, it is not in the atmospheric pressure. We are increasing the pressure up to 10 bar. If you are increasing the pressure, then at what temperature this pure liquid will comes means, if you are increasing the pressure, then around 20 degree itself, the pure liquid will come. If you are increasing the pressure around 40 bar, then we are getting around 5 degree to 6 degree itself, we are getting the liquid. So if we are increasing the pressure, we can reduce the temperature also, we may have some phase change process. So while increasing the pressure will make a phase change process. At the same time, increasing the temperature will also lead as a phase change process. That means if you are taking as a gold material, okay, for an example, or iron material, whatever it may be, you can take any one of the material. Okay, iron material is going to heat it up to 10 degrees centigrade. What happens? Nothing happens. Iron material is going to heat it up to 40 degree room temperature. What happens? Nothing happens. It is in the iron material. Okay, if you are heated up to 600 degree, 700 degree, 800, 900, 1000 degree. So what happens after it beyond this melting point? We know that each and every one of the material is having a melting point. So after that melting point, if the temperature is above that melting point temperature, then what happens? This material is become into the liquid state. This material is become into the liquid state. Okay, so this is the phase change process. So this temperature is also improving. That means if you are increasing the temperature, then we may able to get the phase change process. So pressure and temperature, these are the both two elements are most involved in the phase change process. So what is meant by phase? A phase is defined as a chemically homogeneous portion of a system that has a particular chemical composition and structure. So chemical composition is nothing but if you are considering alloying element. If you are considering alloying element, then two or more elements will be presented over the material. So on the time, if we are melting that element, then what happens? The chemical composition of that material is having some different instincts. So this has to be found out with the help of this phase diagram. If you are considering water in liquid or vapor state in the single phase, ice floating on the water is example in the two phase. That means if if you are having ice cube, if you are applying around 200 degree to this ice cube, then what happens? If you are applying 200 degrees centigrade to this ice cube, what happens? Straight away it is converted into gaseous state. That's all. So that is not the liquid state process. That means we can able to increase the temperature. Then depends upon the temperature, the phase change can be processed. So we all know about that. The temperature and the pressure is the most important parameters while considering this phase change consideration. Thank you.